person don't join. One person don't join. Why are these shadows? Why are these shadows here? I can't start. They've not joined. This is 0. One person joined before, now it's showing 0. Nobody has joined. One person just joined now. Okay, keep joining, keep joining. We are going to start right now. We are going to start right now. We are starting right now. All right. Ephraim, Akbabi, welcome. Let's wait for the others to join. Ephraim, let's wait for the others to join. All right, so somebody else joined. I can see Dara Solo. Okay, Dara Solo just joined. Okay, we are just 2, 3. Okay, we are doing great. We are doing very great. We are starting right away. We are starting right away. We are starting right away. Okay. Okay, let's start. Let's start. We are just 3 here. We are just 3. Please try to use the comment section very well this time. The live session will last for just 1 hour. So tonight, we are just going to do barely part 1. So we are doing just 2 topics. Then we are climaxing it tomorrow with the remaining 2 topics. I don't want us to stay too long on the live. Okay, we are 4. We are coming up. We are coming up. Share the link with your friends so that they can join. Share the link with your friends so they can join. We are 4 now. We are 4. Many are we know? Still 4. Many are we know? Still 4. All right, so let's begin. Let's begin. So this is how we are going to do it. Since we had some network issues initially, we are going to start from the beginning, starting from question number 1. So this is my question number 1 here. This is my question number 1 here. Now it says aluminum hydroxide reacts with HCl of stomach water and aqueous aluminum chloride. How many grams of HCl react with 2.5 grams of aluminum hydroxide? Now we have options A, B, C, and D. So we're going to solve this problem. Then we are going to choose from the options the correct answer. Now I would like you to take your time to solve this problem for the next 30 seconds. Then I'm going to attempt the problem. Let's start. 30 seconds. Your time starts now. Once you are done solving the problem, drop your answer in the comments. Let's verify. Okay, any answers? 3.51. Okay, I hope you're not giving me this answer based on what we solved initially. All right, so I have a 3.51 and that corresponds with option C. Now let's solve it together. Now, from that problem, now anytime you're given a stoichiometry problem, the first thing you're going to do is that you're going to write out a balanced chemical equation. Now, let's write a balanced chemical equation for the reaction. I'm going to be very, very quick on this one. So we are given that aluminum hydroxide, this is the formula for aluminum hydroxide, AlOH bracket 3. We are told that it gives us water alongside aluminum trichloride. Let's write a balanced equation for the reaction. So to balance this equation, we are going to start by saying how many chlorine atoms are on this side. We have just one here. We have 3 on this side. So I'm going to put a 3 as a coefficient here. And the 3 balances chlorine on both sides. How many hydrogen atoms are on both sides now? We have 3 atoms of hydrogen here plus this 3, making it 6. How many on this side? We have 2. So putting a 3 here makes it 6. On this side, we have 3. How many here? We have 3. So we have a balanced chemical equation. Now let's get right into the question. The question says, how many grams of HCl react with 2.5 grams of aluminum hydroxide? So this question connects aluminum hydroxide. I have 2 reactants being connected here. And we are going to be working in grams. So first things first, let's give this equation a mass interpretation. What do I mean? What is the molar mass of aluminum hydroxide here? And what is the molar mass of HCl here? Let's get that out. Don't forget that aluminum is 27, oxygen is 16, hydrogen is 1, and chlorine is 35.5. So solve with me. So what is the molar mass of aluminum hydroxide in the balanced equation? The molar mass here is 73. How did I get 73? 27 plus, this is a bracket here. So I have 16 plus 1, that's 17, multiplied by 3. Then add it to 27, and that gives me 78. So I have that 78 grams of aluminum hydroxide will always react with, what is the molecular? So I know that hydrogen is 1 plus chlorine 35.5. That gives me 36.5. Then when I multiply that by 3, that is going to give me 109.5. So I have 109.5 grams of HCl. So that is what I have from the balanced chemical equation. Now, the question is asking us, how many grams of HCl will react with 2.5 grams of aluminum? So that gives us 2.5 grams of aluminum hydroxide will react with how many grams of HCl? So I'm going to cross multiply. So 2.5 multiplied by 109.5 divided by 78 of HCl. So the final answer here is 3.51 grams of HCl. So this corresponds with option C in the problem. Check it out. Option C, 3.51. Now let's solve question number 2. For question number 2, we are going to be talking about a limiting reagent problem here. Limiting reagents. Now the question goes this way. It says, what is the percentage yield of barium sulfate if 11.67 grams of barium sulfate were obtained by reacting 26.13 grams of barium nitrate and excess sodium sulfate? To solve this problem, first things first, write out a balanced chemical equation for the reaction. This problem looks just like, I'm solving question number 2 now. This problem looks like this. The equation looks like AB plus CD to give us AD plus BC reaction. So let's write out the parameters we're given. So we are given that 11.67 grams of barium sulfate were obtained by reacting 26.13 grams of barium nitrate. So we have that barium nitrate combines with sodium sulfate. Let's write it out. So this is barium nitrate, BaNO3 bracket 2, combines with sodium sulfate, Na2SO4. So this is going to give us barium sulfate, BaSO4 plus sodium nitrate, NaNO3. All right, so we talked all about this in class, and I guess this is really very clear. Now, next thing, you're going to balance the chemical equation here. So we have 2 atoms of sodium here and 1 atom on this side. So you're going to put a 2 here to balance that equation. Now, doing that, you have balanced the entire equation. Now, let's now go right into solving the problem. So what are the given parameters here? So we are given that the actual yield here is 11.67. How do I even know that this is the actual yield? How do I know? Now, the question says, what is the percentage yield of barium sulfate? Now, look at how to identify the actual yield. Now, it's always given like this. If 11.67 grams of barium sulfate were obtained, now underline that statement there. If 11.67 grams of barium sulfate were obtained by reacting this amount of barium nitrate and excess sodium sulfate. So yield here, let me write it out. Actual yield is equal to 11.67 grams. So this is the actual yield of barium sulfate. So that is the actual yield. So the next thing we are going to do is we are going to find out the theoretical yield. The theoretical yield of barium sulfate is unknown. Now, once we find the theoretical yield of barium sulfate, you can now get the percentage yield using the formula percentage yield is equal to the actual yield over the theoretical yield times 100 over 1. We are going to apply this formula, but before that, we need to find the theoretical yield. How do we find the theoretical yield from the given problem? Now, let's check out the problem. Now, from this problem, we are going to use this given mass, which is 26.13 barium nitrate. We are going to use this particular given mass here to identify the theoretical yield of barium sulfate. Let's do that together. Now, let's get back to the balanced chemical equation. From the balanced chemical equation, we are going to be comparing barium nitrate with barium sulfate. Let's do that together. From the balanced equation here, what is the molecular weight of barium nitrate? Don't forget that barium, let me write it on this side. Barium, Ba, the molecular weight of barium is about, let me check. The molecular weight of barium should be about, I want to be very sure of that. It should be about 137.33. Please note it down. Barium is about 137.33 grams. This is the molar mass, or let me say the atomic weight of barium. So note it. So let's calculate the molecular weight of barium triazonitrate 5. So let's do that together. So I have that 137.33 plus, I'm doing this now. I'm opening a bracket. Nitrogen is 14, so I have 14 plus O is 16 multiplied by 3. That gives me 48. I'm multiplying by 2. All right, so that's the total mass here of barium nitrate in grams. BaNO3 bracket 2. So this gives me what mass on the product side. What is the molecular weight for barium sulfate? Let's check it out. 137.33 plus sulfur is 32 plus Oxygen is 16, multiplied by 4 gives me 64. So everything here is in grams of BaSO4. All right, so let's do this together. So from this, we have that. From this, we have that 261 grams. We have that 261 grams. Oh, sorry, I missed the decimal. 261.13 grams of barium nitrate will always produce, let's sum this up. This is going to give you about, let me see, 233.33 grams of barium sulfate. All right. So from the balanced equation, if you balance that equation properly, you get that 261.13 grams of barium nitrate will always react to produce 233.33 grams of barium sulfate. Now back to the question. Now from the question, we were given that, let's go back to the question, we're given that 26.13 grams of barium nitrate reacted here, right? So let's use it now. So 26.13 grams of barium nitrate is expected to produce how many grams of barium sulfate? Let's cross multiply. We're going to have 26.13 multiplied by 233.33 divided by 261.13. So what's the final answer here? We are going to obtain, let me see. Please work that out. We're going to obtain what? We're going to obtain 23.33. So we have 23.33 grams of barium sulfate. What we just calculated right now is called the theoretical yield of barium sulfate. Now, let's go through the solution again. What have we done so far? First things first, we balance the chemical equation. Next, we are given the actual yield as 11.67 grams. We are looking for the theoretical yield. Now we are going to use this formula to find the percentage yield. Now next, we need to find the theoretical yield. From the balanced equation, we have that 261.13 grams of barium nitrate produces 233.33 grams of barium sulfate. That's from the balanced chemical equation here. We can see that from the balanced equation. So 26.13 grams, which was given, we produce what amount of barium sulfate? Now, what we just obtained right now is called the theoretical yield. Calculate for the percentage yield, and that will be our final answer. So the percentage yield right here is going to be percentage yield of barium sulfate will be equal to actual yield, which is 11.67 grams, over the theoretical yield we just calculated for, which is 23.33. Let's do that. 23.33 grams multiplied by 100, and this gives us 50%. Check your answer. Is the answer in the option? If the answer is in the option, which option is it? If the answer is in the option, what is the correct option there? Check. Drop the comment, or let me say drop the options in the comments. Let's see the correct option. So what's the correct option going to be here? Check my options. Look at my question 2. All right. Correct. I'm seeing 49.7% here. That's correct. That's almost approximate. Now, if you check the options here, the correct option here is option B, which is 50%. So the answer is option B, 50%. If you got 49.7, you are close, and that is very perfect. I love that. From Rosaline Epo, you are doing perfectly well. I love that. Yes, B. Option B is the correct answer. Now let's go to question number 3. Let's go to question number 3. Now, while I'm solving question number 3, I would like you to pay rapt attention to how I'm going to solve this. Are you ready? If you're ready, type yes in the If you are ready, type yes in the comments. Let's solve question number 3. That's the third question for today. All right. Question number 3. Yes, sir. Perfect. I love that. Let's solve question number 3 now. Now, question number 3 says, let me read. Question number 3 says, a sample of an organic compound, in brackets, containing carbon, hydrogen, and oxygen, weighing 0.684 grams, was burned in oxygen to give 1.312 grams of CO2 and 0.805 grams of H2O. What is the empirical formula of the compound? Let's solve this problem. Now, this is similar to the problems we've solved in class on empirical formulas. So let's write out the given parameters here. Don't forget, I'm solving question number 3. Question number 3. All right. So that's question number 3 right there. Now we are solving that right away. So what are the given parameters for question number 3? For question number 3, we are given that mass. We are given that mass of sample is equal to 0.684 grams. So that's the mass of the sample given there. Now, we are told that when the sample was burned in oxygen, it gave 1.312 grams of CO2. So I would say mass of CO2 is equal to 1.312 grams of CO2. Now, from the question again, we have that 0.805 grams of water was produced. So mass of water is equal to 0.805 grams. Now, what do we do next? Next, we are going to obtain the mass of carbon in the sample. How do we obtain the mass of carbon in this sample? How do we do that? To obtain the mass of carbon in this sample, we are going to do a very simple stoichiometry. Now, don't forget that the products obtained from this combustion process are carbon 4 oxide and water. And between these two products, which of the products can we find carbon? The answer is carbon 4 oxide. So I'm going to use carbon 4 oxide to find the mass of carbon in this compound. So this is CO2. I'm going to consider CO2 right now. So in CO2, the molecular weight of CO2 is 44. We all know that, right? So the molecular weight is 44. So simply meaning that 44 grams of CO2 contains how many grams of carbon do you think are here? We have just one atom of carbon, meaning that we just have 12 grams of carbon. So 44 grams of CO2 produces 12 grams of carbon. Or you can say that 44 grams of CO2 contains 12 grams of carbon. So therefore, 1.312 grams of CO2 is expected to contain how many grams of carbon? Now, at this point, you can cross multiply to get the mass of carbon in the sample. Can we do that together? Cross multiply. That will give you 1.312 multiplied by 12 divided by 44. So I have 1.312 multiplied by 12 divided by 44 grams of carbon. So that will give us what? Let's say punch that. Let's have the answer in the option. Punch that, punch that, punch that. Let's see, punch that. What is the answer to this calculation? 1.312 times 12 divided by 44. What are we going to get from there? 0.358. I love that. From precious earth, beautiful. 0.358 grams of carbon. So this is the amount of carbon in the sample. Now I want us to get the amount of hydrogen in the sample using the same formula. Now mass of hydrogen in the sample. How do we get the mass of hydrogen in the sample right now? How do we do that? Now, this is how to do it. First things first, the same method we used here. Don't forget, we're going to be analyzing H2O because water contains hydrogen. Now, what is the molecular weight of water? The answer is 18. Water is 18. So we can say that 18 grams of H2O contains, how many grams of hydrogen do you find here? The answer is 2. Contains 2 grams of hydrogen. So therefore, from the given quantity, 0.805 grams of water, so 0.805 grams of water is expected to contain how many grams of hydrogen? Now we do the same arithmetic, you cross multiply. So 0.805 multiplied by 2 divided by 18 grams. So what is the mass of hydrogen here? Do the arithmetic. Let's get the answer in the options. Hurry up. Do the arithmetic. Let's get the answer in the options. I'm seeing 0.089. That is beautiful. That's the correct answer. So we have 0.089 grams. Beautiful. So now at this point, we have the mass of carbon and hydrogen in the sample. Now pay attention to this. Pay attention to this. Now, if you want to get the mass of oxygen in that sample, now it does not really make sense. It doesn't really make sense trying to do the same process because you will not get the correct answer. So how do you find the exact mass of oxygen present in this sample? Now, this is what you're going to do. Now, mass of oxygen is equal to mass of sample minus bracket minus mass of what? Mass of carbon plus mass of what? Hydrogen. Close this bracket. Now use this formula every time to find the mass of oxygen. So if you want to find the mass of oxygen, you're going to subtract the total mass of the sample from the combined mass of carbon and hydrogen. Let's do that together. So what is the mass of the sample here? Is giving us 0.684. So 0.684 minus. So open this bracket. What is the mass of carbon we obtained from this calculation? What did we get? We obtained the mass of carbon to be 0.358. Okay. Plus, I'm adding it with the mass of hydrogen we just got is 0.089. So what is the mass of oxygen? So drop the answer in the comments. Let me see. Drop the answer in the comments. Precious, I'm seeing 0.197. Is that what you got? I need to confirm that answer from somebody else. 0.197. Somebody else should confirm that. Is that the final mass of oxygen here? I'm now seeing 0.238. All right, I think we have to do that together to verify. Let's not go with wrong answers. All right. All right, let's do that together. So we have 0.358, sorry, 0.358 plus 0.089. All right, so 0.0447. Okay, so 0.684 minus that 0.684 minus 0.447. So the answer is 0.237. So the answer is 0.237. Beautiful, beautiful. I like that. So 0.237. Now let's calculate the empirical formula of this sample. And that's going to be very, very simple to do. Are you ready for that? Let's do that together. Empirical formula. Empirical formula. So how do you find the empirical formula? Let's arrange all the atoms in place. We have carbon, we have hydrogen, and we have oxygen. So what was the mass of carbon we calculated for? The mass of carbon we got here was 0.358. All right. So what was the mass of hydrogen we got? 0.089. What was the mass of oxygen we got here? 0.237. All right. Now, next thing we're going to do is that we're going to divide each of these masses here by their atomic masses. What is the atomic mass of carbon? 12. Atomic mass of hydrogen is 1 and oxygen is 16. Now, provide the answers in the comments. Let's see. What is the mass here? Or what is the answer here for the first one? Carbon. Carbon will give us how many moles? How many moles are there for carbon? Give me your answer to 3 decimal places. How many moles of carbon do we have here? I need a response in the comments. Okay, I have 0.029 from Precious Ebe. Beautiful. All right, 0.029. Okay, let me verify that. I'm seeing 0.30. Why are you approximating that? 0.029 is fine. How did you get 0.030? Okay, Ezekiel, I'll check that. All right, so let's move on. So for the next one here, we have 0.089. Now, I need the answer for the last one. 0.237 divided by 16. How many moles of oxygen are there? Check. How many moles of oxygen are there? I need answers from you. Drop it in the comments. We are getting to serious problems now. Rosaline, I'm seeing 0.029 grams of carbon. Okay, we are done with carbon. We are talking about oxygen now. Okay, I'm seeing 0.014. Is it for oxygen? Someone should verify. 0.014. Beautiful. So we have 0.014. All right. I'm seeing 15 now. What's going on? Let me see that. 0.237 divided by 16. I have 0.0148. Yeah, I think let's add the 8 now. Yeah, 0.0148. Yeah, making sense. 0.0148, which is 0.015. I like that. All right, so what do we do next? Now, let's divide through by the smallest value. What is the smallest value here, guys? What is the smallest value, guys? Drop the answer in the comments. What's the smallest value there? What's the smallest value there? Check. What is the smallest value there? Compare these 3 answers here. Which of them is the smallest? 0.0148. That's beautiful from Louis Vic 28. That's beautiful. Okay, from David Christopher, beautiful. From Loretta, Loretina, that's beautiful. All right, now let's go there. That's the correct answer. So we are going to divide through by the smallest value, and that is dividing through by 0.0148, 0.0148, 0.0148. Now, what are we going to get as our answer? Let's check. Drop your answers now. Let's see. Now, for carbon, what is the answer for carbon? Drop it. 0.029 divided by 0.0148. Let's check it out. 0.029 divided by 0.0148. Okay, I'm having 1.95 there, which is 2. So I have 2 there. I have 2. Now let's do the same thing for hydrogen. 0.089 divided by 0.0148. 0.089 divided by 0.0148. I have 6 there. I have 6. I have 6. Okay. Now let's do the same thing for oxygen, and that'll give me 1. All right. So for oxygen, I have 1. So the empirical formula here is C2H6 and what? O, final answer. Now let's check for the correct option, whether we have it there. So what is the correct option here? The answer is option C. Write it down. Option C is the correct answer. Option C. You are correct. You guys are doing very well. Option C is the correct answer. C2H6O. Let's get down to question number 4. Question number 4. Are you ready? Question number 4. Question number 4. This takes us to Avogadro's concept. This takes us to Avogadro's concept. So let's solve question number 4. Question number 4 says, how many formula units are present in 123 grams of magnesium cyanide? Let's solve this problem. Now, I want you to listen to this. By the time we solve this problem to problem number 5, we are going to stop the live section for today and continue tomorrow because it's already getting late. So by tomorrow, we're going to continue the live session and we're going to start a bit earlier, let's say around 7:30, and we end by 9 o'clock. So by then, we should cover the remaining 3 topics. So let's solve problem number 4. So for problem number 4, how many formula units are present in 123 grams of magnesium cyanide? Let's solve. How many formula units are present in 123 grams of magnesium cyanide? Now let's start like this. What is magnesium cyanide? If you don't know what magnesium cyanide is, you cannot solve this problem. What is magnesium cyanide? Okay, now look at magnesium cyanide here. We have magnesium, this is question 4, Mg, magnesium. Cyanide ion is Cn minus. So we all know that magnesium is in group 2. We have Mg2 plus, and this is cyanide. So what will be the correct formula for magnesium cyanide? It will be MgCN bracket 2. So this is the correct formula for magnesium cyanide. So now let's go straight to the problem. How many formula units are present in 123 grams of magnesium cyanide? Let's start like this. Now, 1 formula unit of magnesium cyanide contains how many grams? Don't forget, magnesium is equal to 24, carbon is equal to 12, and nitrogen is equal to 14. So let's use this to calculate the molecular weight of magnesium cyanide. Let's do that together. Let's do that together. So we have that 24 plus, open a bracket, carbon is 12 plus 14, close the bracket, multiply by 2. And this will give us 12 plus 14 is 26. 26 times 2 is 52. 52 plus 24 is equal to, drop the answer in the comments. I want to be sure you're following. Drop the answer in the comments. Okay, I love what you're doing. Rosaline Ebo, you're doing perfectly well. I love that. So drop the answer in the comments. What is the molecular weight for magnesium cyanide? I just did the calculation now. So we are going to have what as our answer? Check. 76 is correct. 76 grams is the answer. All right, so let's continue our solution now. So magnesium cyanide is equal to 76 grams. So it is very clear that 76 grams of magnesium, I can take there. 76 grams of magnesium cyanide is equivalent to 1 formula unit of magnesium cyanide, and it contains 6.02 times 10 raised to the power 23 atoms. So 1 formula unit of magnesium cyanide contains 6.02 times 10 raised to the power 23 atoms, according to Avogadro's concept. So don't forget, Avogadro unit of any compound contains Avogadro's number of atoms. So from the question says, how many formula units are present in 123 grams of magnesium cyanide? So what do? Let's try this out. So 123 grams of magnesium cyanide is supposed to contain how many atoms? How many atoms are going to be present here? I think this question has issues. It should be how many atoms are present in, it should be how many atoms, not formula units. So we are going to correct this in class. So how do we solve this problem? So we are going to cross multiply, right? So we cross multiply, and that will give us 123 grams. Okay, forget about the grams. 123 times 6.02 times 10 power 23 divided by 76. So what will be the final answer here? How many atoms are present here? So what should do? We drop it in the options or in the comment. Let's see. How many atoms are going to be present here? How many atoms are going to be present here? Check, 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 check. Okay. If you've done this with me, you're going to get your answer to be option A. That is beautiful. I'm saying 9.74. That is beautiful. So that corresponds to option A, which is 9.74 or 9.7 instead, approximately 9.7 multiplied by 10 raised to power 23. So that's the correct answer. Option A is the answer, atoms. So the question is supposed to be asking us how many atoms are present in 123 grams of magnesium cyanide. So that's an error there, not formula units. Okay, let's go straight to question number 5. Beautiful. I'm seeing correct answers from Ezekiel Hefzeba. That's beautiful. You guys are doing very well. So let's go straight to the last question for today. Now, don't forget, in our live stream today, we are not going to solve all the problems. We are not going to solve all the problems. We are going to stop at question number 5 for topic number 1. Then, in our live stream for tomorrow, we are going to cover the remaining problems, covering chemical kinetics, molecular geometry, and thermochemistry and thermodynamics. So we are going to cover those ones tomorrow. So let's solve question number 5. All right. I love the response. Yeah, I love the responses I'm getting. Okay, let's solve question number 5 now. Question number 5. Please, if you have questions, drop it in the comments. Let me respond before I answer the last question for today, question number 5. Questions, drop it in the comments. Let me see. Questions, drop it in the comments. Let me see. No questions yet. No questions yet. So we are moving straight to question number 5. That's the last question for today. I'm still waiting for your questions. What time tomorrow? Tomorrow is going to be by 7:30. 7:30 p.m. where we're ending by 9. 7:30 p.m. to 9 p.m. 1 hour 30 minutes. We're covering all the entire topics we treated so far. Okay. So question number 5. Question number 5. Let me get it out. I think some parameters are missing there. Let me get it out. Question number 5. Question number 5. Let me get it out. Okay, I think I have it now. Question number 5. I think I have it now. Let me see. Okay. All right, please write it down. Okay, no need. So question number 5 says, a compound of sodium has the following composition. So I'm going to fill in those compositions right away. So a compound of sodium has the following compositions: 17.5% of sodium. Okay, let's write it down. So we have 17.5% of sodium, 0.5% of sodium. Then we have 39.7% of chromium, 39.7% of chromium, and 42.8% of oxygen. 42.8% of oxygen. All right. Now the question says, what is the empirical formula of this compound? Let's solve it together. What is the empirical formula of this compound? Now, don't forget, we've been given the percentage compositions of these elements, starting with sodium. Sodium is, let me see, okay, sodium is 17.5%. Chromium is 39.7%. And oxygen is 42.8%. Let's solve this together. Before we solve, you need to understand that sodium is equal to 23, that is the atomic mass. Chromium is equal to 52, that is the atomic mass. And oxygen is equal to 16. Now let's solve together. So we're going to divide each of these given percentages here. Don't forget, these are percentage by mass value. So you can refer to these percentage values here as the what? As the masses. So I'm going to divide through by their atomic masses. So I'm going to say 17.5 divided by 23 divided by 52 divided by 16. Now let's do this together. Now, punch for sodium. Let's get the number of moles. Drop it in the comments. Let's see. How many moles of sodium do you have there? Check. How many moles of sodium do you have there? How many moles of sodium do you have there? I'm waiting. 0.76. Okay, Precious, 0.760. Precious, you are doing very well. So we have 0.760. Okay, I think you can still approximate that. 0.761 is still great. I like that. So we have 0.761 moles of sodium. Now let's get the number of moles of chromium. Someone should do that for us. For chromium, how many moles of chromium do we have? Let's leave our answers to 3 decimal places. You are good to go from there. How many moles of chromium do you have there? Someone should drop it in the comments. Moles of chromium. How many moles of chromium do we have? Okay, I can't find chromium. 0.763. All right, I love that. So chromium is 0.763. I'm so proud of you. 0.763. All right. Now, how many moles of oxygen do you have there? That would be the last. So how many moles of oxygen do you have there? How many moles of oxygen do you have there? All right. I love your answers. Your answers are great. Okay, Precious, 2.675. Okay, I think we'll go with that. 2.675 is great. Yeah, 2.675. All right, so that's the number of moles of chromium, also of oxygen that we have there. Now, looking at these 3 values, which of them do you think is the smallest? Let's work with the smallest value now. What's the smallest value here? The smallest value is what? Drop it in the comments. What's the smallest value there? What is the smallest value there? 0.761. Okay, Louis Vic 28. Thank you very much. 0.7. Now we're going to divide through by the smallest value there. So, like saying divide through by 0.761. So that will give me 0.761 over 0.761, 0.763 over 0.761, and 2.675 over 0.761. So this will give us 1, this will give us 1. What would this give us? Check. What would this give us? The last one will give us what? Check. 2.675 divided by 0.761. Now leave your answer to one decimal place. Leave your answer to one decimal place. Leave your answer to one decimal place. What did you get? 3.5. I so much love this answer. 3.5 from Ezekiel Hefziba. So we have 3.5. Can someone else give us another thing? Let's see. 3.5. Rosaline, I'm seeing 1. Where is the 1 coming from? Okay. 3.5 is great from good. Oh, sorry, Darasolo. That's good. 3.5 is great. 3.5 is great. 3.52 is also good, but I need the answer to one decimal place. 3.5 is great. All right, so that is the answer to one decimal place. Now, pay attention to this. I want you to pay attention to this. This is the last thing we're going to do for today. Now, some persons always make mistake here. Look at these points. You always make mistakes here. This is a very critical point in calculations under empirical formula. So whenever you solve till this point, take note of the following decimals. Pay attention here. Now, anytime you come across a 0.5, now I want to show you 3 important decimals you might see during your calculations. If you come across a 0.33 or a 0.67, you need to multiply these by 3. I'll tell you why. Now, if you use your calculator and you check 1 over 3, 1 over 3 is equal to 0.333. So if you want to make this a whole number, you multiply by the denominator. So to make 1 over 3 a whole number, I will say 1 over 3 times 3. This will give me 1. All right, so anytime you encounter a 0.33 at this point, look at this point here, multiply through by 3. Or if you encounter a 0.67, what is a 0.67? A 0.67 is the same thing as saying 2 over 3. If you do 2 over 3 in your calculator, you're going to get 0.6666, which is approximately 0.67. So how do I make this a whole number? I multiply through by the denominator. So therefore, 2 over 3 multiplied by 3 gives me 2. That's a whole number there. So to make this particular decimal a whole number, multiply through by what? By 3. So look at this. So anytime you encounter a 0.33 or a 0.67 at this stage, multiply everything here by 3. Now let me show you another special decimal. We just encountered this one now. Anytime you encounter a 0.5, a 0.5 example could be 1.5, it could be 2.5, it could be 3.5, it could be whatever 0.5. So anytime you encounter these special decimals here, you're going to multiply through by 2. Why are we multiplying through by 2? Now take your calculator, do 1 over 2. 1 over 2 is going to give you 0.5. That's what 1 over 2 will give you. So how do you make 1 over 2 a whole number? Is by doing 1 over 2 times 2, which gives you 1. So anytime you encounter a 0.5, multiply through by 2. Now, we just encountered a 0.5 here. So how do we get our final answer from here? I'm going to multiply through by 2 because I just encountered this 0.5. So I'm going to say 2 times 1 will give me 2. 2 times 1 will give me 2. And 2 times 3.5 will give me 7. So this will be my final answers here. 2, 2, and 7. So therefore, the final answer to this question is to be Na2Cr2O7. because my answers are 2, 2, and 7. So what would be the correct answer according to the options? Now look at the options and tell me the correct option. What's the correct option here? Check it. Drop it in the comments. Let me know you're following. What would be the correct option here? Drop it in the comments. Let me know you're following. Option C is very correct. Yes, that is the answer. Option C. We have Na2Cr2O7. Perfect, perfect. You are doing well. You are doing well. You are doing well. Loretina, Stanley, you guys are doing perfect. The answer is option C. All right. Now, I don't know, can we solve problems on the second topic, or do we just end the live? Because I'm suggesting we end the live and continue tomorrow. What do you think? Drop your suggestions in the comments. Let me know what we're going to do next. Do we continue, or do we just end the live and continue tomorrow? All right, all right, all right. That is beautiful. So we are going to continue the live tomorrow. So for now, we have solved 5 unavoidable problems on stoichiometry. So these 5 problems we solved today are very, very important, stoichiometry. So tomorrow, we are going to be doing the second part of this video, where we'll be covering problems on chemical kinetics, rates of chemical reactions. We are also going to cover problems on thermochemistry and thermodynamics. And we're going to cover problems on molecular geometry. So I'm going to see you guys tomorrow for our live video. Thank you so much for coming around despite your busy schedules. I will see you tomorrow. Thank you. Thank you, guys. Thank you, guys. Do have a wonderful night. I'll see you tomorrow by 7:30 p.m. dot. We'll begin our live tomorrow. Thank you very much. Good night, everyone. Good night. Good night. Good night. Thank you. Thank you very much. Okay. Okay. Let's see if we can find the problems.